hopefully by now we're getting into the swing of things. Today is your Friday video, March the 18th, and we're going to go over sections 11.6 and 11.7. 11.6 is all about similar triangles. Now, if something is similar, it means it has the same shape, but not necessarily the same size. Those two triangles are similar, but they're not congruent. Congruent means they have the same shape. But there's certain characteristics of similar triangles. One of the characteristics is for every angle on this triangle, there is a congruent angle on that triangle. So I could say that's congruent to that. That angle right there is congruent to that. And then the third angles are congruent. For two triangles to be similar, they have to have a congruent angle on the other triangle. The other thing about similar triangles, not congruent triangles, but similar triangles, is their sides have to be proportional. So let's say I know that the measurement of that side is 2 and the measurement of that side is 4. Well, then what I have is I have a proportion that 2 is to 4 as each of the other two sides line up. So let's say this is 3, so that would go on the top down here. And to keep it similar, I would have to have a 6 on the bottom, okay? Because these sides are double what that side is. So when I go 3 or 2 to 4, it's the same as 3 to 6. They would both reduce down to 1/2. So let's say I said that side was 5, then hopefully you can figure out that that side would have to be 10. So then 5 is to 10. We did proportion problems before where we labeled them. I might say left triangle and right triangle to keep it straight as to where I put the measurements. That might be something helpful for you. We're going to do an example of a problem that you might have to do using this. And this example comes straight out of your book. It's example number 2. And you have got 2 triangles. And they tell you some of the measurements on those triangles. All right, so those are the 2 triangles, and they give me a similarity statement. So they're going to tell me triangle TUV is similar. Similar is like a sideways S to triangle, and that angle that lines up with T is W. So WXY. So I know those 2 triangles are similar. Well, the first thing I'm going to do is I'm going to look at their angles. If these 2 triangles are similar, and I know this and this are both 98, I know that's 47, then this down here would also have to be 47. If this is 51, this up there would also have to be 51. Now that's taking care of all of our angles. Now we need to look at the sides. So what I might do is set up a proportion where I have top triangle and bottom triangle. Okay, the top triangle, this side right here, has a measurement of 4, and it's comparable to this side right here, which has a measurement of 16. Well, let's say I want to find A. Well, A is comparable to 3. That's going to go on the top. and DA would go on the bottom because it's the measurement on the bottom triangle. I'm going to cross product here. When I cross product, I get 4A is equal to 48. I'm going to divide, and I'm going to get A is equal to 12. So I know that the measurement on that is 12. I go, okay, I want to find B. So again, I do top and bottom. I can use the same, the 4 over the 16, but this time I'm working with the line segment across the bottom. 6 is that line segment on the top triangle. B is that line segment on the bottom triangle. I'm going to cross product here, and I'm going to get 4B is equal to 64. When I divide, I'm going to get 16. So I know that B is equal to 16. So that's how you would use similar triangles to find missing parts. Now I'm going to let you try one, and again, I encourage you to stop the video, do it, and then come back and make sure you got the problem correct. All right, you have two triangles. It's marking the congruent statement with the triangle on the bottom. Now on this particular triangle, they've given you all the parts, and what they're wanting to know, is this a similar triangle? Well, you've marked all the angles, so you know that that follows what you need to follow for similar triangles. So now let's look at the sides, okay? We'll do top, bottom. 15 is to 10, as 12 is to 8. As 24 is to 16. Now the question is, would all of those reduce down to the same thing? Well, let's say here I divide the top and the bottom by 5. It's going to give me a 3 over 2. If I divide the top and the bottom by 4, that's going to give me a 3 over 2. Top and the bottom here by 8 is going to give me a 3 over 2. So I can see that all of the sides are proportional. So I could say triangle X, Y, Z is similar to triangle A, B, C. Okay? And that would be one way that you would have a problem on this. Obviously, these are not congruent triangles. They're not the same sides, but they are similar. They have the same shape and it's proportional. So let's do another problem. On these, you're going to need to solve. All right, take a second, turn off your video or pause your video and solve for X and Y, knowing that these are two similar triangles. All right, hopefully you got your answer now. Again, I'm going to write top, and I'm going to compare it to the bottom. All right, let's say I want to find my y. Well, first I have to look for two sides that I know the measurements on, and that would be these two sides. So I have 18 is to 27, as 8 is to y. Okay, so I'm going to have to cross product these. And that's going to give me 18y on one side and 216 on the other side, I believe. Okay, and I'm going to divide then by 18. So I have 216 divided by 18. It's going to give me 36, which is going to go in there 12 times, okay? So y is going to equal to 12. So that gives me my y value. Then I'm going to do the same thing for my x. So I can go 18 is to 27, but this time I'm working with this line as 18 is to x. Well, you can kind of cheat right here and recognize that 18 times x is equal to 18 times 27, so the x would have to equal 27. I hope that didn't write off of where you can see. So that solves that triangle. Sometimes you have triangles within a triangle, and that might look like this. And I know the distance here is 6. I know the distance all the way across here is 9. I know this is 10, and I'm trying to find that. They also have told me that triangle ABE is similar to triangle ACD. Now on this particular one, it might be smart to go ahead and mark your congruent angles. So if I'm going A is congruent to A, because that triangle has that angle, and that triangle has that angle. B is congruent to C, so I'm going to put a 2 mark there and a 2 mark there. Those two angles are congruent. And then E, which is this one, is congruent to D. So let's say I'm going to call this the little triangle and the large triangle. You name it however you want to name it. Okay, so I'm looking, I want to find X, so I've got to find the side that I know on both the little and the large, and it's the bottom side. On the little one, it's 6. On the large one, it's 9. But I'm looking for the vertical side. So on the little one, it's 10. On the large one, it's X. And then I'm going to cross product. So I'm going to have 6X is equal to 90. And I'm going to divide that. It's going to go in there 15 times. So I quickly find out X is equal to 15. And that's the only thing they asked me on that one. So why don't you try one? Not necessarily drawn to scale, but from here to here is 4. And that whole distance from here all the way to here is going to be 10. And down here is 3. And I want to know that whole distance across here. This is an X, a Y, a Z, a W, and a V, and I know that triangle XYW is similar to triangle XZV. Okay, pause the video, take a minute to do that, and then come back to it and we'll finish this problem out. All right, hopefully you got your answer. Let's do little, big, like I said, however you want to name it. The one thing that I know the sides on both is this top side on both. So 4 from here to here is similar to the 10. And I want to know the bottom. So 3 is comparable to the A. So I'm going to cross product. I get 4A is equal to 30. I'm going to divide. It's going to go in there 7.5 times. And that's going to be my answer for that. Now, you're also going to use this with word problems. There's a word problem in your book on page 618 that we can do together, and hopefully you can see this. It says, Janelle is standing near the Washington Monument in Washington, D.C. The shadow of the monument is 302.5 feet. Janelle's shadow is 3 feet. If Janelle is 5.5 feet tall, how tall is the monument? Well, they've got it kind of drawn out for you. They've got her standing right here. And then they've got the monument over here. And we know that we're looking for X. We know this is 302.5 feet. And we know this is 3 feet. And we know that, let's see, this right here, she's 5.5 feet. Okay, so we're going to set it up. Maybe little too big. So I've got 3 is to 302.5 as 5.5 is to X. Obviously on this you're going to cross product. So I'm going to get 3X, and I'm going to use my calculator for the sake of time. So 302.5 times 5.5 is going to give me 1,663.75. Obviously I'm going to take that and divide it by 3. And I'm going to get the fact that the statue is 554.6 feet. And that's how you use this information with a word problem. All right, that is the section 11.6. We're going to go on to section 11.7. And this gives you a little taste of the subject of trig. Trig is a math where you are comparing angles and sides together and seeing how they're related. So in trig, you have several different things. You have sine, cosine, and tangent. And if you have noticed on any calculator, you will have SIN, which stands for sine, COS, which stands for cosine, and TAN, which stands for tangent. Each one of these, they are defined by an angle and a side and how things are proportional. So let's say that I have this triangle. And let's say I know this side is 4, this side is 3, and this side is 5. And let's say I'm standing right there, and I'm going to call that angle A. If I want to know what the sine of angle A is, the sine is always opposite over hypotenuse. Now, opposite being the line segment that I cannot reach out my